My name is Bowen. I'm a committer of Apache Flink. I'm a senior engineer at Alibaba. Today I want to talk about the integration between Flink and Hive and all the critically relevant pieces around this initiative. Okay. So here's the agenda today. We'll go through the background, the motivations, and the impacts. We'll have a State of Union to look at what we already have in Flink 1.9, which is released at the end of this August, and what's upcoming next for Flink 1.10. And then we'll take some questions. Let's go through the background a little bit. So I'm assuming all the audience already know like what Flink is, what stream processing is, and how to use Flink, right? There's one point I want to just get your attention to is Flink is born with this vision to unify batch and stream processing, data processing, right? And from our point of view, batch is just a special case of streaming. A way to look at this is actually whether it's batch or streaming, it's just a mechanism to process the data. But what's the critically important differentiator between these two things is the nature of the data. So when we usually say streaming, we are actually processing unbounded data streams, right? And when we say batch, we are actually just processing this bounded data stream. So from this perspective, that may help you to understand why we say batch is the special case of streaming. And what are the benefits of this unified data processing vision? So I would like to see it from two perspectives. One is the operation and one is the end user or developer. So from the operation side, I mean, if you come from a big, whether like a big company or small, you may have already in hand like just multiple data systems, right? One system for a specific purpose. And that just comes with so much operational burden and stress. You got to like learn how to operate each system, how their resource management works, how the metric systems works, right? Then you come up with all this dashboard. And all this overhead is just like killing the operation team. But the nice thing about unified data system is that you will end up with a single tech stack, a single deployment. In that case, I mean, like it can be like multiple clusters, but you will just end up with this consistent deployment strategy and operation strategy, right? It's just a relief for our operation team. From the end user's perspective, I would say it's a little bit better right now for developers because you can quickly learn new systems, learn their syntax, get to know their functionalities. But still, it's not very nice to keep on learning all this stuff where they aim to do the same thing, but you have to do it in different ways, right? And another set of developers are just like data scientists and analysts. They are actually not very used to learning all this coding stuff. They are more used to SQL, and they are more used to like just focus on the business logic rather than trying to learn every detailed technical stuff. So a unified data processing system, especially with SQL, will greatly simplify the learning cost for your team members. So I would say this is the two major motivations from the user perspective to have a unified data processing system. Then I want to talk a little bit about why we want to integrate with Hive. Hive, I just checked Wikipedia yesterday, is actually released exactly 9 years So Hive is released firstly on October 1st, 2010. And over just these 9 years, it's actually become the de facto standard for batch processing use cases like ETL, data analysis, or the dashboard within enterprise, right? And if you look at like Fortune 100 or Fortune 1000 company, I bet most of them will have an in-house Hive deployment. And you can see Hive as two-part from a big data angle. The first is just Hive as an engine to do ETL, data analysis. On the other hand, Hive Metastore over the years has actually evolved into this a center of big data ecosystem, right? So if you think about like data schemas, all the like user authentication, access, ACL, all this stuff, it's actually Hive Metastore becomes this single source of truth and the hub for the big data world. And then we look at the use cases. So I would like to also split it into two groups. One is what's new for the existing Hive users or batch users. On the other hand is what's new for the stream processing and streaming users, right? So let's look at the Hive user first. Hive has been, really handy, but it's also famous for its kind of, higher latency, right? And with the new business requirements, Hive users right now, most of these batch or Hive users, they want lower latency to be able to process data in a near real-time or even real-time fashion, right? So to satisfy their business needs. And on this end, for streaming users, we want to be able to access Hive or other data warehouse data. Because, for example, you want to enrich your data in the ingestion when like the streaming data comes, and you want to join it with some like batch data, right? So how do we kind of do something to benefit both groups of users? So as I describe all these scenarios, you may already figure out like what our motivation is and what kind of impacts we will have with these projects. So I just list a couple like motivations, a few motivations here. So for streaming users, we want to strengthen Flink's lead in the streaming space by enhancing its metadata stack. If you have tried Flink before, like 1.9, you know like it's kind of a little bit weak on the metadata management side. So that's what we want to develop and enhance. And we also want to take this chance because it's like integrated with Hive, integrated with the biggest batch system, right? We want to advance Flink's batch capabilities by providing a unified solution for both batch and the streaming use cases via SQL. And we want to enrich and extend Flink's ecosystem and also, of course, promote Flink's adoption. I didn't have like a very good word for this to classify this integration, but we came up with is platform level. So I want to just clarify what platform level means. It's not another Hive on blah blah something, right? You must have heard there's I think already 3 or 4 Hive on something. So this is definitely not that. This integration will be fully on the Flink side. Everything will be in Flink's repository. It will be released as part of Flink's releases so that we can control our own pace, control what we actually want, what we don't want, and not be constrained in Hive's community. Let's take a look at the latest status of this integration in 1.9. I'll just give some very kind of brief and high-level overview. For detailed stuff, you can check out the online documentation. I would like to take a look at this integration from 2 points. Integrate with Hive's metadata and integrate with Hive's data. So let's take a look at the metadata first. As I said, we want to integrate Flink with Hive's meta store and also metadata, and we want to use this opportunity to completely reshape Flink's metadata management capability and stack. So we developed this new catalog API. It's documented in Flip 30, and you can check out the detail. Here's some high-level points for this flip. We introduced brand new catalogs to be able to manipulate some like widely or commonly used objects. The objects you can manage and manipulate on like databases, tables, view, functions, and stats. These are like very common among SQL systems. And there's just this commonly used operations you can do, like create, list, determines exist or not, get, like alter, rename and drop. So overall, catalogs provide you with this capability to manage these commonly used SQL objects. And we introduced like this namespace thing for SQL objects like table, views, and functions. So if you use Flink before 1.9, you know like there's no namespace at all. If you want to reference something, you just give it reference it with the name, right? And right now we came up with this fully qualified or partially qualified name. It will be like catalog name, database name, object name. We already, just spoiler alert, like we already implement catalogs for Hive, but we want to mention that this opens a whole bunch of new opportunity for integration with external systems. So the Hive catalog we already finished, and the Pulsar, if you know Apache Pulsar, is like a new like streaming system. The Pulsar catalog is actually under review, and we have this roadmap to implement Confluent schema registry catalog, and also the catalog for other like message queues or streams. Then you can actually integrate catalogs with all your favorite data management system, whether it's structured or semi-structured. Architecturally, all the catalogs will be managed by a single catalog manager instance within the table environment. So this is a little bit detailed stuff, but just want to mention it here. The next point I think is really handy. We came up with this concept of current catalog and current database. So what it can do is it can like bring really like handy experience to developers. For example, like lousy SQL statement like select star from my current catalog, current database table can be simplified just as select star from table. This diagram shows like where the catalog APIs are located in the stack of Flink. So it's on the table and the SQL layer. Out of shelf in Flink 1.9, we provide 2 catalog implementations. The first is an in-memory catalog. So it's in memory, it's not persistent. You lost everything once you exit the session. And if you don't do anything, if you don't configure anything, this catalog will be used by default. It will be great for backward compatibility, also for like new users to play with Flink. We implement the Hive catalog. It is compatible with multiple versions of Hive. It supports most of Hive's data types. I would say there's only a few of them that are not supported right now, like I think union or something, like not very frequently used. It can read and write Hive metadata. It actually can persist Flink's non-Hive streaming and batch data by using Hive metastore purely as a storage. This diagram may give you a better sense of what that means. So I would say Hive catalog can do two things, okay? On the upper layer, you would say it enables this Hive and Flink interoperability. What you can think of this is if everything you created on the Hive end, Flink will be able to leverage that. And also, you can create Hive-specific objects from Flink by using like Flink as some kind of client or engine. And everything you created from Flink, Hive will actually be able to understand and use that. So it has this round trip concept. And on the lower stack, for non-Hive metadata, for example, you will have a Pulsar or Kafka table that right now you cannot persist anywhere, right? You can actually persist those data like a Hive or the Kafka or Pulsar table into Hive metastore right now. It just Hive won't be able to understand it, and in that case, Hive metastore is basically like a storage backend. This gives us just a brief design of how the catalog works. So we have the catalog APIs, and then we have two implementations. All the catalog will be managed by the catalog manager, and then you can query all the metadata inside the catalog from either SQL client or table environment is just invisible to you. And for Hive catalog, we use a shame layer to support multiple Hive versions by just shaming the Hive metastore client. In 1.9, we officially support Hive 2.3.4 and 1.2.1. A lot more Hive versions are officially supporting 1.10, just to mention here. And we rely on Hive's own compatibility for other minor releases. Another thing with Hive's ecosystem is that over the years, just people have developed so many in-house Hive UDFs, right? And when you want people to try all the different engines that Hive, we just don't want users to re-implement everything. After all, what they care more about is just the business logic and the migration friction. They may just care less about the performance and how we do it. So we decided to support Hive's UDF. I'm glad to announce that like all Hive UDF has been supported in Flink 1.9. Those interfaces include like UDF, generic UDF, UDTF, UDAF, generic UDAF resolver, all these Hive UDF interfaces. But there's one limitation in 1.9 is that you can only use Hive's UDF if your current catalog is a Hive catalog. We will fix that well, not fix, it's not a bug. We'll actually improve that in 1.10, and I'll explain why that's a limitation later. For source and sync, in 1.9, you can already like read and write non-partition Hive tables. You can read Hive partition table our source support partition pruning, and we have officially tested this commonly used file formats like text, sequence file, ORC parquet. I'm pretty sure, like, even though we didn't have a full test to cover all the file formats, I'm pretty sure like lots of the other commonly used ones are supported. Let's just go through a couple examples, okay? One example from the table API and one example from SQL client. So here you can see we first get this table environment, and then we register a Hive catalog by giving it a name like my Hive, and give it the hiveconf directory. So hiveconf, if you don't know, it's defines lots of the configurations for a Hive, like the installation directory, Thrift server URL, all that. And you will say, hey, I want to use my Hive as my current catalog and use my DB as my current database. Then you can get the catalog and you say, like, list all the databases in the catalog, list all the tables under that database, and you construct an object path, say, hey, I want to get my Hive table under my database. And you get the table, and you say list partition, or just throw some queries on the table. On the SQL client side, you will need to first register all the catalogs in the YAML file. So here, obviously, have a catalog section. Oh, actually, sorry, this is you shouldn't have this bracket. So you define the name, you define the type, the DR, and this is optional. You say, hey, which database I want to use as a default upon startup. Then you would just use like commonly use the SQL commands like show catalogs, show databases, then show tables. I want to describe my table. I want to issue some queries, right? So it's pretty simple. We are excited about this. If you haven't tried it yet, please try it out in 1.9, and we'd love to hear from you to get some feedbacks on what we can improve on and what we should work on next. So here's just a brief summary. We released the first part of the integration in 1.9 as a beta. We believe it lays the solid foundation for Flink's integration with Hive. And besides just Hive itself, this initiative actually led us to a lot of development and enhancement around the metadata management stack of Flink. Right now, Flink 1.10 is under the way. I think the target release date is end of November. So I'll just show you guys what we have been working on. So I'm excited that we are finally officially support all these Hive versions. Okay, 1.2, 2.x, and 3.1, and all its minor releases. So we realized like 1.2 and 2.x are probably the most commonly adopted Hive versions. And we are glad that we are officially integrating with them right now. For Hive Source and Sinks, the source will support projection pushdown. So if you have like a really wide table, like 100 columns, but when your query only cares about like a 5 column of those 100, then you shouldn't actually read all the 100 column data, right? And the projection pushdown can save this disk I/O for you. And we are working on support reading Hive views. Hive Sync will support this common syntax in Hive dialect, like insert overwrite. So you can just insert overwrite an existing partition, and it supports inserting into partitions both dynamically and statically. In 1.10, we are right now driving 3 flips, and I want to give you guys an idea like what are these 3 flips about. The first is flip 57, rework function catalog. There are a few problems that we want to solve with this flip. We want to first clarify and complete the function categories. So if you have been using SQL functions in Flink, you know right now all the functions besides the catalog function are actually temporary. Like if you call like a table environment.register function, it's actually registering a temporary function inside the memory, and this will be gone if you exit the program, right? And the definition of this temporary function and how it should be resolved in this function order is kind of ambiguous. So we want to redefine that. We want to be able to allow user referencing functions with either fully qualified name or partially qualified name across catalogs and databases. So this is actually the limitation that I mentioned previously, that when you use a Hive UDF in 1.9, you can only do it when your current catalog is a Hive catalog. So this initiative will actually solve that for you. And we want to redefine some function resolution order. So for the current temporary functions, we want to clarify them and categorize them into temp system functions and temp catalog functions. So system functions, it's you can think of it as just like building, interpreted as building. There are some similarities. They are both volatile, right? Temporary, so it's gone when you leave a program. But there are some like key differences. For temporary system or temporary built-in functions, it will have no namespace. It is built for the purpose to override system and built-in functions. And the corresponding DDL for them would be like create temporary system function, blah, blah, blah. Temporary catalog functions are built to override catalog functions. So it has this catalog and database namespace. And it has this DDL as create temp function. The use cases for temporary functions, what we vision is that you want to, for example, for users want to experiment new functions, but don't actually want to, persist it in anywhere because of like it's experimental, or you don't have access to like the catalog of databases. This would be a great way for new users to just play with Flink and experiment with the functionality, right? As I mentioned, right now in Flink 1.9 and past, you can only reference a function ambiguously, which means just with the function name, like select a function column, then from your table. There is a few things that we want to achieve. First is have this fully qualified or partially qualified name where you can just reference functions across catalog or database, right? For the ambiguous function reference, because we introduced these 2 new function category, so we redefined its resolution order. So when you say function, it actually will look at these 4 categories, and whichever it's found first, it will just use that function. And on the precise function reference side, with regard to the resolution order, because it already has the namespaces, right? So it cannot be system or built-in functions. So the resolution order will just be temporary catalog function, the catalog function. So the second flip is we want to be able to extend Flink's core table system to be pluggable to be like modularized. There are a few motivations here. The most direct motivation is we want to be able to support Hive's built-in functions. So when I was doing a diff between Flink's built-in function or system function and Hive built-in function, in Hive, between Flink 1.9 and the Hive 3.1, I think there are like about 200 built-in functions that are missing in Flink but are existing in Hive. And it would be nice if we can just leverage what Hive already have instead of re-implementing everything in Flink again, right? We don't want to reinvent the wheel. That's the most direct motivation. But when we look at this initiative and we realize it actually can fit into a bigger pattern or bigger initiative or bigger scope, we want to enable users to integrate with not just Hive, but all the other existing SQL systems built-in objects. So you can just leverage what you already have instead of re-implementing everything. We also want to make Flink's core table system extensible. For example, for the upcoming geo module or machine learning module, you will have some customized data types or functions over there, right? And we don't want to bring in that dependency into Flink if you don't use them, because their size can be, a little bit bigger. So in that case, with this initiative, you will be able to load the geo and machine learning modules just as the plugins. So here's a simplified design. It's very much like catalogs. We will have module interface and all these module implementations. All the modules will be managed by a module manager, and then we expose it to a table environment. The last flip, I would say, is most user-facing ones. We want to improve miscellaneous DDL and enhance all the DDLs in SQL and table APIs. We want to have this more complete set of DDLs. This DDLs through unified SQL parser. What I mean unified is actually right now in SQL client you can do a subset of these DDLs, but it's not through this parser, and we are just querying it. We're just parsing it the hard way. We'll say, hey, if this is a create database, then do something. Right? It's not very nice. And actually in table API right now you cannot do a lot with the DDL. So we want to have this unified SQL parser to be able to unify these two implementations. The DDL can just give you some example like create, drop, alter, catalog, database functions. And the sum for tables you could do is create a table as select from another table, right? So that's basically 1.10. And beyond that, we are looking forward to a few other improvements, like more Hive SQL compatibilities. So you don't need to alter your existing Hive SQLs a lot in order to use it in Flink. We want to support more user customized objects. Of course, performance optimization is a critical part for the adoption, and we will research and see other feature parities, enterprise readiness, the security, data governance, and we are officially committed to have regular maintenance and release on this Hive integration. So here's a few of my colleagues and community members that they are actively involved in this project, and I would like to thank them. So here's my talk, and here's some like conclusions I want you to walk out this room with. So starting from Flink 1.9, we are officially integrating with Hive on both the data and the metadata side. This will help Flink to realize its potential in batch processing, and we believe it's a critical step to help Flink realize its vision in unified data processing. We completely reshaped Flink's metadata management capability and stack, and enhanced Flink's SQL. And we hope this can bring Flink like more users and lays like a solid foundation for Flink's enterprise adoption. So that's my presentation today. Thank you all for coming. If you want to follow me on Twitter, I occasionally update like the latest stuff. And I'm also the host of Seattle Flink meetup, so I don't think anyone is from Seattle. Yeah, so I'm ready to take some questions. Yes.
Thank you. You mentioned that you are working on pushing down projection on a Hive.
Yeah.
Is there any plan to do a bit more than that? I suppose that for massive table, the time to load the data from Hive to Flink could be an issue, and perhaps there is a room for pushing down a bit more than projection.
Yeah, definitely. I would say like a projection push down is just one optimizations that we are doing. And of course, the optimizations, there's just so many kinds of optimizations, right? If you have any like specific requirements, please don't hesitate to contact me or send an email to the dev mailing list, and we'll definitely prioritize these optimizations. Projection pushdown is just like one, I think the big thing that I want to mention in 1.10. Just give you another example is with the limitation. What I mean is like when you like explore the data, you will say select star from a table limit 1, right? You just want one record, doesn't matter which one. Yeah, we optimized that in 1.10. So yeah, we'd love to hear about your feedbacks and ideas.
Cool.
Yeah.
Thanks.
Thank you.
Are transactional tables supported in Hive today? The transactional.
Sorry, can you repeat?
Transactional table, are they supported today within the aggregation? Yes, transactional, in fact, or based on orc file.
Let me repeat that. Are you asking about Hive ACID?
Yeah. ACID.
Okay. Yeah. Hive ACID, we researched that, and we don't think it's like a priority for us. Here's the thing. We have 2 Hive PMC in our teams, like in the thank list. According to our experience, is that Hive ACID is not very scalable. So for example, you would say if you want to update 1% of your data in a Hive table, ACID maybe work well, but if you see 5% or 10%, according to our experience, it's not like really working very well. That's why we are right now only supporting like the pin only. ACID may be requirements when we want to make Hive sync like a stream sync. Right now it's mainly just batch, right? What if you want to use it in a streaming use case, right? You read from Kafka and you want to just use Hive data to write to your data warehouse or data lake. So in that case, ACID may came up as a topic, but just according to our experience, and especially the experience from the like two Hive PMCs, ACID is not like a very ideal solution. Yeah.
Other questions?
Yeah, if you want to like grab me after this session, yeah, I'd love to like talk about things that I know and share my experience with you.
All right. Thank you very much.
Okay, thank you everyone.